Welcome friends, in this video we're going to disentangle the mysteries of spatial and temporal periods. Let's take a look at what I mean here. Look on the bottom here. I have a ruler. As long as you know how to read a ruler and a clock, you can understand the difference between the two kinds of periods. The fundamental concepts in science are often quite easy as long as we don't rely too much on fancy symbols to express them. But simple pictures we can all understand immediately. Take a look. So I have a ruler. You know how to read a ruler. This is scaled in inches, for example, so it goes from 0 to 12 inches. And I'm going to start putting down some temperatures along the ruler here. Okay, so for example, at 0 inches right here, I read a value along my thermometer here of 38 degrees right here. Then for example, at 2 inches into this distribution of space, because that's what a ruler essentially measures, the distribution of space, that there is 37 degrees. At 4 inches, I'm back up to 38 degrees. For example, at 6 inches, I'm at 39 degrees. And at 8 inches, as you can see, I'm back down to 38 degrees. So that is, as you see, a spatial period of 8 inches. It takes 8 inches of space for a cycle in the temperatures to repeat. Cycle means 38, 37, up to 38, up to a high value of 39, and then back down to the starting value of 38. That is what we call one cycle. And it takes 8 inches of space, so that is the spatial period, 8 inches. Now, spatial periods can be adjusted, obviously. They can be big, small, and so on. Take a look here. I'm going to spread this out over a larger amount of space. So, for example, now, as you see here, the spatial period has been enlarged. And specifically, you see it takes 12 inches of space now to repeat a cycle. So the spatial period is 12 inches. They can also be compressed. What I mean by that is, I'm going to put these together closer, and it's going to take less space to complete a cycle. So in this case, the way I've arranged these, it takes, for example, only 4 inches of space for the temperatures to go through a cycle. So this spatial period is only, for example, 4 inches. As I said, as long as you know how to read a ruler and read a clock, you can understand the difference between the two. Now, this is one possibility. You can have a spatial period, and then it can be very long or very short, depending, for example, on specifics. Next, I'm going to move these aside deliberately, and we're going to study a different kind of period. Take a look here. I have my thermometer deliberately fixed at 0 inches. I could, if I wanted to, fix it at 1 inch or 1.5 inches, or for example, 1.75 inches. That's not too important, in fact. So for the sake of convenience, I have it fixed at 0 inches, and we call that a fixed spatial position, the fixed position in space. And here I have basically what amounts to like a little temperature gauge, and by default, at t equals 0, when we start measuring our time, it's set to 38 degrees. And I'm going to do this. Take a look. I'm going to turn on my clock, and I'm going to set the timer. Take a look. Let me delete this one, it's too short. I'm setting a timer to 10 seconds. And let me reset that. And I've done that on purpose. I want to track, for example, the position or the temperature gauge, for example, as time passes. So I can understand the concept of a temporal or time-based period. Look carefully. I'm going to do this to the best of my ability. I'm going to start the timer and look. You see? The temperature gauge is changing, so it's reading different temperatures, and it takes about 10 seconds. It took 10 seconds of time for the temperature gauge to go through a complete cycle back up to 38 degrees. Now, as before, for example, as in the case of spatial periods, you can modify temporal periods in a variety of ways, in fact. Take a look. I'm going to take this. I'm going to go back to the timer, and here, take a look. I'm going to delete this timer. I'm going to set it to 20 seconds. And what have I just done here? Think about this. I just doubled the period. So I'm going to stretch the temporal period by a factor of 2. It's going to take twice as long for the temperature gauge to go through a cycle. Look. That means 38 over to 40. See, back down to about 38. And then down to about 36, and then back up to about 38. You see? It clearly took twice as long for the cycle to repeat. As before, you can also make these periods shorter. So in other words, you got to move faster along the thermometer. Take a look at what I mean. I'm going to set this new timer to 4 seconds. That's super. I need to stop that and reset it back down. And now I'm going to repeat the cycle over a period of 4 seconds. Very short period of time. I'm going to do the best I can. And you see that took about 4 seconds. Let me stop that. So that's another kind of temporal period value there, 4 seconds. So as in the case of spatial periods, temporal periods can be long, or maybe they can be very short, depending on the specifics. And one last thing that I want to talk about here, let me switch over to the clock. If I just look at this thermometer with that reading on it, observe something important here. Look, time is clearly flowing. Time is always flowing for all of us. And as time flows, you see that this temperature reading is set at 38 degrees. It doesn't change. It doesn't go up or down. Nothing like that is happening. So when you have a quantity you're measuring over time, as time passes against the passing of time, and if that quantity does not change, essentially you say that quantity is independent of time. When it does change over time, then it's clearly dependent on time. That's it for this one. Thank you so much. If this has been helpful in terms of understanding the difference between spatial and temporal periods, please leave a like, and I'll see you in another physical math video.